Alright kiddos, happy Halloween. This video I'm going to show you, I'm going to derive the derivatives for both the sine and the cosine functions. So here we go. We're going to work from the limit definition. So recall that the derivative of a function f is the limit, as h is going to 0, of f at x plus h minus f of x all over h. And of course, this guy in here, that's the little slope of the secant line, average rate of change. And then when we impose that limit, the 2 points get wicked close together, therefore resulting in the derivative, the instantaneous rate of change at any moment. Okay, so let's take a look at the sine and cosine function. Today in class we developed some shortcuts, some rules for power rule. For example, constant rule, coefficient. Here is similar exploration of the derivative of the sine function. Okay, so using the limit definition, it's going to be the limit as h is going to 0 of the sine of x plus h minus the sine of x all over h. Okay, and a little stuck right now, but notice that I can work with that. That's the sum rule, and I can replace that with, by identity, the sine of x cosine h plus switch roles, sine of h cosine x, and I'm going to bring down this little piece right here. And that's all over h. So just by identity, I just substituted the sine of a plus b with its appropriate identity. All right, now what I'm going to do is factor a little bit. And what I can note is that there's a sine of x here and a sine of x there. So here is sine x, there is sine x, everywhere sine x. I'm going to factor out a sine of x just from those two terms. And I'm left with a cosine h here, minus, when I factor out a sine of x, a 1 there. And then, of course, I have to remember that there's this little middle term in here I got to bring down, plus sine h cosine x. And that's all over h, right? So one way to write all over h is I can split them up, put them both over h. Okay? The reason that we factor that sine of x out is because now I can rewrite each particular limit in a helpful way. And so this limit is sine of x times, and now what's left is cosine h minus 1 over h. Okay, so all I did was I just took this piece here and put it here. Okay, because what we're going to do is evaluate that limit in a hot second. And what I'm going to do on the right is something very similar. I'm going to pull out the sine h over h and then bring the cosine in front. I'm just going to change the order around a little bit. Okay, so all I did was really I just took the sine h over h, brought it there, multiplied it by cosine. Okay, so I just rewrote it a little differently. Now I'm going to take each limit. Okay, notice that this limit, obviously, as it always does, has to do with h. Right? Not all the terms have an h in it. So what I'm going to do is this cosine of x just comes right down, times, and then the limit as h is going to 0 of this guy, I wonder what that is. Whoop, whoop. Oh, what do you know? I got it all graphed up, ready to go. So I'm going to take a little peek at the limit of cosine h minus 1, in this case cosine x minus 1, all over x. But as x is going to 0. So here's a graph, and I'm just going to kind of take a peek from the left of 0. Looks like we're heading towards 0. Of course, at 0, it doesn't exist. We're going to go to the right of 0, and it looks like we're also heading to 0. And so, in fact, that limit is indeed 0. So I've evaluated the limit as h is going to 0, cosine of h minus 1 all over h. I'm going to do the same thing over here. The cosine of x doesn't have any h in it, so it's irrelevant. Times, and now, I guess I should be a little bit more accurate here. This limit way out here, again, kind of works on this last piece right there. And there's our sine x over x as x is going to 0, or in this case sine h over h as h is going to 0, and we know from experience that that is 1. Okay, so at the end of the day, the derivative of the sine of x is equal to, well, 0 times sine of x, so that's just 0, plus cosine of x. So it just leaves me with cosine x. Okay, so therefore the derivative of the sine function is the cosine function. Ha, that's crazy. So we can add this to our rules. Okay. Now let's look at the derivative of cosine function. And we're going to do it in the same way. And I'm going to rip through this a little faster because it's very similar in structure. So, using the limit definition, the derivative of the cosine function is limit as h is going to 0, cosine x plus h minus cosine x all over h. Right, I'm going to use the cosine sum identity to rewrite cosine of x plus h. And I'm going to rewrite it as cosine x sine h. Oops, nope, that's not how I'm going to rewrite it. Cosine x cosine h, there we go, minus sine x sine h. And again, that's just by identity. Okay, the cosine of a plus b, goodness gracious, is indeed equal to cosine a cosine b minus sine a sine b. Okay, so I just use our identity for that, minus this guy at the end, cosine of x all over h. And just like I did with the sine function, I'm going to factor out. Factor cosine, which is part of 2 out of the 3 terms up top. Right, and what I'm left with when I factor out here is cosine of h. When I factor cosine of this, just minus 1. And then I bring that term down. And again, that fanciness, I can split up. Everything's over h. So I can split it up into the difference of the 2 ratios, all over h, both over h. And now I'm going to do a little fanciness here. Cosine x times, and here's my cosine h minus 1 all over h. Right? And then minus sine of x times, here's my sine h over h. Just a little algebra. Right? And of course we're taking limit as h is going to 0 for all of those terms. And again, because h is going to 0, we don't care about the cosine, it's just cosine of x times, and then the limit as h is going to 0 of this guy, we already saw, we conjectured by the look of this graph, that that's equal to 0. And indeed it is. Minus sine of x, again that has no h in it, and it's the limit as h is going to 0, times, and here's our old friend sine h over h as h is going to 0, which we know to be 1. Okay, so at the end of the day, the 0 times cosine x goes away, and we're left with minus sine of x. Okay, so therefore the derivative of the cosine is negative sine of x. Okay, so just like our power rule, our coefficient rule, our linear rule, our constant rule, our sum difference rule, these are 2 rules we're going to add to our repertoire. Hope you have a great Halloween trick or treat. We'll see you tomorrow.